kinds of photographs. And as I said earlier, this the very first picture of the Earth that we see of the moon from Apollo 8 was something that we never expected. The astronauts never expected themselves, because they saw this view and they say, "Oh my God, do you see that?" And they ran out to get the camera to take a photograph of it. And that one picture became maybe the title page of the Apollo program, because it showed us, number one, that the Earth is a planet. The Earth is a beautiful planet, and it is one little thing. And as the astronaut said, we don't see any boundaries. We don't see the borders between countries. We don't see such and such, and it's all the same place. And moon, they began to look at the surface features, and then we wanted to certainly take as many photographs of the surface in detail, so that we can use these photographs for the selection of landing sites as much as we can possibly apply, knowing that we think about the rockiness of the surface and getting away from rough territory. Next. And so the things that we realized was the fact that, yes, indeed, that you have the view from the lunar, or from the command module would allow us to have enough photographs to select the landing sites properly. And we did for Apollo 11, and then we got the shock of our lives. Because during the Apollo 11 mission, we selected a 7-kilometer area where we know for sure that there is absolutely flat areas in there that they can land in, and we took the best one to them, and in the center, and the spacecraft was supposed to be directed towards that one. And they came down as prescribed, and lo and behold, it was not going. The spacecraft was not going where they thought it was going to, and it was going to land over a small crater with lots of blocks in it, and these blocks were big as desk-sized blocks. And Neil Armstrong had to maneuver by hand and take the spacecraft and put it away from that thing. And we realized that only afterwards we realized that as the command module was separating from the command, as it was releasing the lander was there was an increased velocity, and the command module did not. We thought that the landing site would be here, but as the lander came in, it came further down by 7 kilometers and was going to land in the middle of a crater. So it missed the site that we had selected by a few kilometers, and therefore Neil Armstrong had to, by hand, manually move it away from that rockiness to save the mission. Next. Okay, and now they started going to walk on the moon. And one of the first things that we asked them to do is to take a picture of the footprint, because we wanted to know the thickness of the regolith, the very fine-grained layer, how much we know how much he weighs and how much he would sink in this layer, and because we knew that this kind of thing will remain there, so that we measure the shadow, and we know exactly the depth of this thing, and which means how what's the grain size of all of the dust material on the surface of the moon. Next. And then became the training of the astronauts and looking at the moon from orbit, in addition to the fact that the astronauts on the surface would describe the surface of the moon as they walk in, and they take samples and they describe the setting of the samples and so on. We wanted to have some more discussion of what is it that you can see from orbit, because the orbital observation help in selecting landing sites after that mission. And here we're talking to Stu Rusa, who was the command module pilot of Apollo mission 14. And so this, after the Apollo 13 mission, this became a very important, significant thing to land correctly and do it right, and then so that, because we had several missions, we're supposed to have up till Apollo 20. It not ended with 17. We had up till Apollo 20 missions to go to the moon, and so observations from lunar orbit were very significant to do so. And next, please. And we would take the Apollo program, the Apollo photographs taken from previous missions, and show them show the new guys what all of these things, and in addition to the fact that some of the information is coming in from the looking at describing the surface material and as well as the rocks and so on, that we have additional material, additional knowledge from the orbital observations. Next. And came this Apollo 15 mission, Al Worden, and Al Worden was a great observer. He really wanted to do it right, and he wanted to absorb as much as possibly can, and he became one of the best observers of all kinds of features. And while he was on Apollo 15 mission, he looked at the ground in a place that I asked him to look at, and he described it very nicely, and he said that there are actually volcanic eruptions in there, darker rock material, so this is an additional younger volcanics because they're darker looking and so on, and made a big deal out of it. And even Rocco Petrone, who was the Apollo program director, from a distance he pointed and came down to say, your student may have picked up a landing site for you. So he knew exactly what these statements may mean, that Al Worden describing younger volcanics and cinder cones very much like the ones that we saw near Flagstaff, Arizona, this kind of thing, that he said maybe that will be a push for one of the later missions, and indeed it was the site for Apollo mission 17. Next. And so the Apollo Command Module observations were very important, because in addition to the fact that we had also cameras, in that one metric camera to take real good topographic maps of the moon, and one panoramic camera which took very high resolution pictures so that we can see details down to a few meters of the surface of the moon. Next. Apollo 16 came, and this was the one place on the moon that we selected that was not exactly what we thought it would be. We selected a place near the central part of the moon whereby there are all kinds of hills like this, and Don Williams and I thought of them as hills that were actually built up by volcanic action in the highlands, and so we called them the Faro Terra, and the NASA headquarters loved it. Rocco Petrone loved this statement of Faro Terra. So what makes the Faroes, and what is Terra, and all of that. And we started sending it as the pile-up material, and not very different from the volcanics of the basalts. This will be such and such. And here comes the Apollo 16 crew, and they go up there and look at it and begin to say, well, this is all breccia. We're looking at. It was proved that the rover that we had taken was very useful, even though it was used for Apollo 15 and 16. But Apollo 17 was exceedingly useful to allow the astronauts to go to sample a mountain range and then go to sample a different crater in the south, and then go east and have another look at a completely different crater. So it was the use of the rover was wonderful, because it allowed the astronauts to drive away from the landing spot for 7 kilometers, and the 7 kilometers was actually not a limitation of the rover. It was a limitation of the oxygen tank that they carried, because they said if one oxygen tank goes kaput, say let's by a micrometeorite or something breaks it, or something little meteorite hits it and zaps it and it breaks, then they can actually, the two astronauts can actually breathe oxygen from the one tank, but that will take them for up to 7 kilometers of walking, and that's it. And therefore we said that the Jeep could not take them further than 7 kilometers from the spot. So there were limitations also that were placed on the human aspect, or the human needs up there on the moon. Next, please. And so the Apollo 17 mission, we were able to train them with images taken by Apollo 15, because we had very fabulous cameras, the metric camera and the panoramic camera, and we had magnificent images that they could actually see for Apollo 17, because the Apollo 17 track was close to the Apollo 15 track. So on Apollo 15 we had taken all of these magnificent pictures, so the Apollo 17 crew could use them. And here is we're talking to show these images from on the machine during the training program. Next. And the Apollo 15 mission, because of the availability of the rover to take them as far as regions away from them, they could collect a rock. Here you can see a geologist, Jack Schmidt, picking up a piece of this huge block that fell from high up on the mountain, and we knew that a piece of rock that is very high on the mountain would be different from the compositionally from the rock on the surface of the moon, and indeed it was. So that allowed us to get as much variety of the lunar surface materials as possible. Next. The tracks of the rover will be there forever. Because there is no wind, there is no rain, so these tracks will be there on the moon forever. So we'll know what mess up that we did from the moon will be recorded forever. Next. The rocks were, but the samples showed that the rock materials of the moon were very much like those of the Earth. There are some differences chemically. There are some concentrations of elements that are precious elements, maybe. There are some higher concentrations of thorium, of lithium, and some elements that are not on Earth or very different from the concentrations on Earth. But basically, the rocks are very much like the Earth's material, formed in very close to the way they formed on the Earth. So the geological processes that we are familiar with on Earth would most likely function on all the planetary bodies with differences in their environmental conditions or something or other, because of the size, because of the distance from the sun, because of the original composition. But whatever we learned on the Earth in geology, we can certainly apply towards all of the planetary bodies. Next. And we learn naturally that from the crystals that we see from the microscope. It's because we see exactly the same kind of patterns of rocks on Earth. Next. Then we came here to the Smithsonian Institution to establish the Air and Space Museum, and one of the first things that we did was to think about Apollo. And my good contribution, in addition to all of the kinds of things that we talked about, the scientific material and so on, and what did we do, and I wrote the script for the little movie called The Man in the Moon Remembers, whereby we wanted to show, because we didn't have much space to talk about the science, because of the rockets and so on, the part of this Saturn V, and all of the other the most important things that took the astronauts to the moon were there to, they just took most of the space. So the little movie of the Man in the Moon Remembers was to just summarize the history of the moon by saying that for about 4 billion years ago, the whole effort of going to get that one piece of the moon for people to share. Next. So there are all kinds of little things that happen like this that make a huge difference, and so that several missions afterwards showed us the features of the back of the moon, the far side of the moon, the details of it, and you can see there are no features of man in the moon. It is all of this white rock. There are very little of the dark volcanic or mare basalt. Next. And then there are all kinds of things now for the Japanese mission going to this southern region of the moon, because we know that there may be ice, water ice, in the southern polar region of the moon, because of the fact that it is in shadow all the time. So if there is some water, it can be frozen as ice, and it can remain right there in this area. Next, please. And we now, the latest mission is actually next after that. The last mission now is the Chinese mission, whereby there is the Chinese landed a spacecraft, and they have a little rover. They actually move away from the spacecraft to investigate part of the far side of the moon. So this will allow us to consider what the chemistry of the far side might be, as opposed to the chemistry of the near side, if there are differences in the chemistry between the two, just because of the lock of the Earth. So there are all kinds of things of the moon that were still talked about. There are people that think today about the potential of a mission to the moon to stay, and potential for